Hey Flight Simmers, welcome back to the channel. Today I will show you how to connect LCD displays to the flight sim. It's not in particular for my Airbus A320 cockpit, it can be used for every kind of aircraft. This is what it's all about. Today I got two LCD screens, one 16 by 2 rows and one 20 by 4 rows. And as you can see, I have assigned several parameters to the displays. I will show you how to connect the displays to the Arduino board and how to set up all the parameters inside the displays. To have a starting point, you can just download the configuration file for MobiFlight. Just follow the link in the description. It's free for download. If you're new to the channel, please subscribe and hit the bell. But now let's head over to MobiFlight and connect the LCD display to the flight sim. Now let's have a closer look to the displays. Here I got two displays, one 16 by 2 rows and here 20 characters in 4 rows. And this large one is basically a collection of several values of my Airbus cockpit. It's not a particular display, it's just a summary with different values. And here you can see the rudder trim, and this one is actually in the cockpit and the pedestal. And these two displays are a great example to show the connection in MobiFlight with these displays. And it's pretty nice, especially the rudder trim. By default, when it's trimmed to 0, there's this leading character, the L. And when we trim it to the left, you can see the value changes, but when we're trimming to the right, it changes from L to R for right. And this is a great example in MobiFlight to handle preconditions, to respond on a value and do different things when a value has a particular state or value, for example. The rudder trim, and here the frequencies for the radio. When I switch between standby and active, you can see it changes as well. The SQUAWK code over here, when I change it, it changes as well on the display. And when I'm changing the speed or the heading, it changes on the display. Pretty nice. And first, before we do all the configuration in MobiFlight, let's have a look on the displays in general. Here you can see our basic 16 characters in 2 rows display. And usually these displays are connected to the Arduino or to every other type of microcontroller with 16 pins. And to be honest, it's a real pain to connect the displays with these 16 pins to the Arduino. It's a lot of wiring, and if you imagine when we are connecting several of these displays to one Arduino board, we are running out of pins very quickly. But as you can see, these two displays are connected to the Arduino with just 4 wires. And as you may guess already, 2 is the ground and red is plus 5 volts. So there are just 2 wires left, in this case white and green. And why don't we have to connect 16 pins? Because I'm using an I2C controller. And these controllers allow us to connect multiple displays to the Arduino board with just 4 wires. And now let's have a look on the I2C protocol and how it actually works. I've created a little wiring schematic over here, 2 displays. Those are both 16 by 2 characters, but it doesn't matter. It's all about the controllers over here. And as you can see, ground and 5 volts are connected to these ports on the Arduino. And there are just 2 wires left, SDA and SCL. SDA is the data pin. On this pin, all the data that should be shown on the displays are transmitted, and the clock SCL is used for synchronizing the components, this I2C controller and the Arduino. And when you have a closer look on the Arduino board, there are 2 pins, SCL and SDA, exactly for this protocol, and it's very convenient to connect it to the Arduino. When we have a look on my Arduino board, I connected ground and plus 5 volts over here, and SDA for the data and the clock, it's connected on this side. And both of the controllers are wired in parallel. So every data, either for the right or the left displays, are transmitted over the same data pin. And now we have to assign, or how does the display know what transmitted data should be shown? Because on one case I want to show some text on this display, and in another case I want to show it on the other. So I have to address both of the displays, and therefore both of these controller boards have little jumpers on the side. Here are 3 jumper pads, and when you apply a little drop of solder to one of these solder pads, the address of this controller board changes. This is the documentation for this particular controller board, and by default it has an address of 27. This is a hexadecimal value, but it just says 27. Just ignore the 0x. 0x is always an indicator that it's a hexadecimal value. So each digit has a value from 0 to 9 and A to F. And the 0x is just an indicator that it's a hexadecimal value. And for the displays, these values or these addresses are very common, from 20 to 27, and by default the value of the controller is 0x27. That means that all the jumpers are open. There's no solder connecting 2 pads with each other. So if I do nothing with one of the displays, both displays will have the same address, and both displays would respond to a value change that is addressed to 27. But in this case, I have on the lower display there is a rudder trim, so I have to change the address for each of the LCD screens. For the large one, there is no solder applied to any of these solder pads, so all the jumpers are open, and therefore the address of the large display is still 27. But when you have a look on this one, on the first jumper A0, there's a little drop of solder, and if we have a look in the mapping table, L means a closed jumper. I have assigned a drop of solder to A0, and when there's a 0 is closed, this address of the rudder trim is 26. And that's how easy it is to address several of these displays with the I2C protocol. To connect it to the board, both of the displays, I have a little hub. It's just a basic prototype board where I soldered the DuPont connectors to, and this one goes straight to the Arduino board, is connected over there, and from here both of the connectors are in parallel and leading to the two displays. And the I2C protocol is very powerful just by the fact that we just need 4 wires for the connection. And there are tons of applications for this I2C protocol. This one is not related to my cockpit. I tried to be a guitar player for the past 25 years, and this is a little project I created a while ago. This is a MIDI switcher. It's sending MIDI data to my FX processor, and just like the FX processor itself, I wanted to have these little displays to show the value or the value change for each of the buttons. There are several banks I can switch to, and then each switch has another application or functionality, and therefore I just wanted to have the text on top, and all of the 6 displays are connected to Arduino. Inside there's an Arduino Uno, and when I press a button, it sends MIDI data to my FX processor. It doesn't matter how it works. It's just to show you that there are many applications for the I2C protocol outside of our cockpit. When we have a closer look on the inside, here's the Arduino Uno on the back side of this board. There is a Arduino Uno, and from there, like I have in this example with our cockpit displays, there's just 1 wire leading to this little hub for the I2C with plus 5 volts, ground, and the data and clock pin. And from there, there's 1 connector for each of the displays, and this goes to the displays you can see over here. So pretty straightforward, and I don't need that amount of pins like in the past with all the 16 pins of this LCD screen. I just use 4 with the I2C protocol. Okay, now let's get finally into MobiFlight and do the setup for both of the screens. And this is the configuration file. And there's a lot going on. On the outputs, on the inputs, there is nothing over here, but a lot of output. Let's create a new configuration. And as always, we start with the configuration of the Arduino board. There are 2 displays connected, but I just remove these 2 displays. And now I have a blank configuration. You can see there's nothing shown on the displays. For adding display to the configuration, right click, add device, and here is the LCD display. We name the first one display 4x20. And the display settings, the address. There are several addresses over here from 0x20, 27. These are the most commonly used addresses for the displays, but several more. But I use for the 4x20 display, it's the default address of 27 because I haven't closed a jumper on the controller board. It's 0x27, and change the columns to 20 and the lines to 4. Let's add another display, add device, that's the LCD display. Now I have to switch the address from the default address to 26 because I closed the first jumper, A0, and when this one is closed, it changes the address to 26. The columns are 16, lines are 2. That's great. And name it display 2x16. And don't forget to upload the configuration. Okay, now the board configuration is done, and already you can see on the displays, MobiFlight rocks, definitely. They did a great job on the LCD displays. I don't know exactly when the I2C protocol has been introduced into MobiFlight, but it should be over the past few updates, and it's really great. So MobiFlight, thank you very much. It would be really nice if you donate some money to MobiFlight because they are saving us so much work with connecting all these stuff to the cockpit. I'm not related with MobiFlight, I don't get any money, but I want to share a little bit of appreciation for the work. It's really great what they've done so far, so thank you guys. Okay, now let's connect the two displays to the sim and let's get some values, and we will start off pretty easy with a simple value, and from there we will increase the difficulty over time. And the easiest parameter I can show is I want to start with the SQUAWK code on the I2C display over here. Add a new row and simply give it a name, SQUAWK, go to edit, search for SQUAWK. There it is, A32NX, it's my fly-by-wire A320, the SQUAWK code. And now we can just display it directly to one of the LCD displays and change the type to LCD display. I've connected two displays to the board, and now just delete with the delete key, just delete all of the existing characters. And now when you're typing $4, each of the $sign represents one digit of the SQUAWK code. So we have 4 digits. Now I need $4. Hit OK. Run the configuration, and as you can see, 7,000, there it is. Let's go back. Now what happens when I delete $1? Then you have just the trailing zeros over here. When I change it to 1, 2, 3, 4, now you can see just the 3 and 4 is displayed. So that's very important. The $sign, it's just a placeholder for the digits of the value. So that's pretty easy. We can switch to the other display, 2x16. Okay, and now the SQUAWK code is shown over here. If you want to add a little space to the value, just add some spaces, and now it's in the middle. If you want to set it to the next row, set it to the next row. And there is my SQUAWK code. I can create a label as well, just hard-coded text, SQUAWK, and there it is. So pretty nice. And when I'm changing the value in the sim, it changes here as well. So that's pretty easy to just show a simple value on the display. It doesn't have any decimal points or something, so that's pretty easy. Now, for now, I don't want to connect it directly on a LCD screen. I just want to store the value in this line. So as you can see, the flight sim value is 2222 and the output value as well. And later on, I want to use this line, this parameter, to show the actual configuration, because later on I want to deal with several different values, and I'm in just one configuration line. It's not possible to collect all the data for the heading, for the speed, for the SQUAWK code and the frequencies, and therefore I don't print it directly to the display. So the display is empty right now, but it's stored in this line of configuration, and later when I change this one to display, I want to display a value for example, on the 4x20 and the last row, SQUAWK, and later on I want to have the frequencies on top and the speed and heading on the right, and I want to use just this row for the display of all the values. And now let's have a look on the modify page, because there is a very useful area and the config references. I can add a reference, and in here I can use the SQUAWK. I give it a placeholder, use whatever you want, percent or a dollar, exclamation mark, but it's very important that these placeholders are not contained in one of the labels we are assigning. So for example, I just leave it as an exclamation mark for now, and when I go back to the display, insert the placeholder, the exclamation mark, okay, and here you can see the SQUAWK. But what happens when the exclamation mark is in this label, for example? There is an exclamation mark as well, and now you can see there's 2 at the end of the SQUAWK, because now it displays the last digit of the SQUAWK code over here, because I've used the exclamation mark. So when you're assigning the placeholders on the config reference tab, it's very important that none of these placeholders are contained in any of the labels. I leave it as an exclamation mark for now, just delete it from this label. So now we have already the SQUAWK code. Now let's add the speed and the heading to the large display. And like we did with the SQUAWK, just add a new row, give it a name, speed, for example. Go to edit, and now I want to capture the value of the speed in the flight control unit. And I can try to search for SPD, and there are several for the A320 from fly-by-wire as well, but I don't know exactly which one to use. And for this, it's very useful to have a look on the documentation page on the fly-by-wire A320 on the Flight Control Unit tab. You can open up the API documentation, and in there are the several parameters we can capture. Like here you can see the speed knob, autopilot speed selected, value from 0 to 399. That looks really nice. Let's copy this one, go back to MobiFlight, paste it over here, and this one, okay. And now you can see the flight sim value is 150, output value is the same. We will have a look on the output value in a minute. For now, it's identical to the flight sim value. And when I'm changing the speed, it changes over here as well. Go back to the display, just drag the display to the bottom. And now let's add a speed, SPD. And of course, on the MobiFlight Modify tab, we have to add a reference. There's already a placeholder defined, and on the display page, just add the placeholder. And now we have added the speed to the display. And when I change it in the sim, it changes on the display as well. Let's do the same for the heading. It's pretty simple. Add a new row, change the name to heading, go to edit, open up the documentation, Flight Control Unit, the API documentation, and the heading knob, heading selected, copy the name, go back to MobiFlight, and there are several. Let's try the first one, 95, this looks good. All right, and now you can see it's 96, and there is this leading 0 is not in this value because it's an absolute value, and leading zeros are not shown. When it's in 3 digits, it's okay, but we will handle this in a minute, that we always have the leading 0 over here. Go back to display. On the display page, heading, and of course we need the reference to the heading. Like this. And now there is the heading, but with 2 digits. But like in the sim, I want to have this leading 0. And there's a simple way to do this. And I just duplicate this row, give it a name, and name it less 100 or lower than, and this is greater than or equal to 100. And now I just want to show one of these configurations, but depending on the value of the heading. If the heading is lower than 100, I want to add leading 0. In the other case, I just want to show the value as it is in the sim. So let's go in here, just make it inactive, the second one. We will do this in a minute, but when I have a value lower than 100, I want to add a 0 over here. a hard-coded 0, just 2 digits from the value. And now I add a precondition. We haven't covered this yet, but it's a great opportunity to have a look on the precondition. And now I add a new precondition. No, sorry, remove it. We can use this one, it's set to none, but now move it to config item. Choose the config item, the heading, and if current value is lower than 100, now please have a look on this row, the display lower than 100, when I'm changing the value in the sim. 98, 99, and now when it changes to 100, there is an exclamation mark, and that's an indicator that the precondition we don't have this precondition. The heading is now greater or equal 100, and so this configuration will not be executed. And let's go on with the second one. Let's go in here and change it to config item as well, the heading. If current value is greater or equal to 100, this configuration should be executed. And now you can see heading 100. I'm going to turn up the knob and have a look on the exclamation mark over here. When it's lower than 100, it switches. Now the precondition of the second row isn't there anymore, but it is with the display lower than 100, and now this configuration is executed. So when you turn the knob, you can see the exclamation mark is changing between the both configurations. And this is a great example for the preconditions, and we will use it quite a lot for the rudder trim in a minute. Now we have the SQUAWK, the speed and the heading. What's missing on the large display are the frequencies. Let's add it. Frequency active. Search for frequency. And here you have VHF1 standby frequency, and there should be the active as well. There it is, COM1 active frequency. Okay, and here you can see 118.305. Let's have a look on the frequencies. There it is. But there is this decimal point is missing over here. Let's go to the display. And now I have to add the frequencies to both of these configurations for the display. Let's start with the active one, greater 100. Go to the modify and add a reference, frequency active. It's the add symbol. And active. And now I'm adding 6 add symbols over here. Hit OK. And now I have the active frequency, but there is still the decimal point missing. So there are two ways to do this. The easiest way is just to add a point over here. And now there is a decimal point. You can do this, it's not a problem. But there is a second way to do this. Right in this tab frequency to change this one. Go to edit, and on the modify page I add a modifier. I want to transform this value. The dollar symbol is the value of this configuration. It's the 118305, and I can just divide it by 1000. And now you can see 118.305, but now on the display you have 2 decimal points. I don't want to have this one. Go back to the active display and delete this point. And now we have to add another add symbol because there are 7 characters including the decimal point, and now the decimal point is in there. Let's copy this frequency act and rename it to standby, and select the standby frequency, and on the modify page it's the same, just divided by 1000, and the value is 118.015, and just add it to the display. Standby. On the modify page, add a reference, standby. But now, please be careful. Now we have the placeholder A, and I'm pretty sure that we have an A over here. So we have to choose a different type of placeholder. I will go with %. 2, 3, 4, 5, 6, and one more. And there's my standby frequency. Let's add this little arrow in the middle. And now the active frequency, standby, the score code, speed and heading are included. But when I'm changing the heading again, now you can see there is this other display configuration active, and now I've lost the frequencies. So I can either go to the edit page and add all the references, but in this case I just duplicate this row, change the name to lower than 100, and change the precondition. Lower than 100, and in this case I want to add the leading 0 over here. It's much easier to do it this way than add all the frequencies and labels and so on in this configuration. Now let's give it a test when we change the heading. Now the second configuration is active, but the frequencies are still in there. So great, this display works just fine. Now let's have a look on the rudder trim. It's a little bit more complex with preconditions, but it's just like we did with all the other values over here. We have to add a little bit more preconditions to it, but it isn't that difficult. Let's go on with adding a new row for the rudder trim. go back in the documentation, go to the rudder trim, and in the API documentation, here's a rudder trim PCT. This should be the value. One match found, perfect. Hit OK. Let's go into the sim. No, but it's not the right value. It doesn't change in MobiFlight. Okay, let's have a look again. A32NX rudder trim angle. It's not in the documentation. All right. Hit OK. And now you can see there is a value. And now, as you can see, the value of the rudder trim has a lot of decimal places, and I want to get rid of all the decimal places after the 4. And you can see already in the sim it's 1.5, and here it's negative 1.45. So this in the flight sim is a rounded value. Go to the rudder trim, go to edit, modify, and add an expression or a transform, and you can use a round function with 1 decimal place. And here you can see the flight sim value has all the digits, and output value is now just negative 1.5. Let's change it. Yeah, we have the same value as in the sim. That looks really nice. Back to 0. Now we have still value in the flight sim value, but because we round this value, it's 0. This looks really nice. Now let's add a display for the rudder trim. Go to edit, go to modify and add a reference, the rudder trim. Display, we want to display it on the 2x16. Delete all the existing characters. A label, and in the second row add the placeholder. I add 3 digits. Now it says rudder trim 0. Let's go and change the value. This looks nice, but as you can see, when write 1.0, it's just 1. So we have to handle this in a minute with a precondition. Change it to 0, and with 0 we have this issue again. On left. Now I have -1. Okay, there's still something to do. And now I have to add some preconditions. So for the -1 case, so for this case, I have to add a precondition for 0 and for right 1. Yes, for 0 and for this one. There are several ways to do this. The easiest way is to change the output type of the rudder trim. I don't want to have the output value to 1 or with a decimal place. I just multiply the value inside this transformation by 10. Now it's 13. Let's go back to the rudder trim. And on the display tab, add the decimal point manually. So now let's go to 1. Yes. Now on 1.0, this is okay. And from there, everything that's greater than 1, it still looks good. But when it's lower than 1, now I have this leading 0. This is missing. Okay. From there, back to 0. There is the 0 missing as well. And on the negative side as well. And from -1, it looks good. And just by multiply the value by 10 and add the decimal point by hand, I have to define less preconditions like I have to do with the original value. So let's go into the rudder trim, and now let's add a precondition, because we have to add the R and the L character as well. Now let's add a precondition. The config item, the rudder trim is greater or equal to 1. Then I want to have the R and the value as it is from the sim. Alright, now it's not active because the value is lower than 1. But when I go to 1, now it's active, and rudder trim R1.0. And from there, everything that's greater is in there. Perfect. But now when I go back, I have to change it to greater than 10 because I multiplied it by 10. Now the configuration is not active. Go back to 1. Now it works because I have here the rudder trim value is 12, and from 10 to 0 I want to have a different precondition. Now you can see rudder trim is not active. Let's duplicate this row, give it a name, greater or equal 10. Lower 10, and greater 0. I'll just use one end. It's I'm a software developer, and in there, when you're using this condition, you do use two ands. Okay, this value is lower than 10 and greater than 0. Then this configuration should be active. Let's change it. Greater than 0, and add a second precondition. The rudder trim lower than 10. So in this range from 0 to 10, this configuration should be active. And in there, I will add the leading 0. Let's give it a check. Already there's a R 0.9 over 10. The first configuration is active. Yeah, you can see the exclamation mark. It's switching between these configurations. And when I go to 0, none of these configurations should be active. That's the case because now it's 0. So none of these configurations fulfill the precondition. Let's add another one. Duplicate this row and greater -10 and lower or equal to 0. Then add the L character in here, precondition. Let's change it. Greater than -10 and lower or equal to 0, then this configuration should be active. And now, as you can see, it's active. Go back to 0. Okay, now when I come from right trim back to 0, there's the R, and it's depending on the direction you come from. Now it's L, so I will by default, when it's set to 0, I will have the L character over here. But if I go below the value of 10, now there is no configuration active over here. Let's duplicate this row once again and just name it lower than -10. Go to the precondition, remove the first one, set it to -10. On the display tab, just add the placeholder. All right, well, now when you're scrolling through the values, you can see in MobiFlight the exclamation mark. There's switching between the configurations depending on the preconditions. So pretty nice. And now I've done the setup for both of the displays for the rudder trim and this large screen with all the different frequencies and speed and heading and the SQUAWK code. And now you have a brief overview of how to handle displays in MobiFlight. So it's very easy to connect the displays to the flight sim. And later on we will use this again to build up the battery voltages over here, or the frequencies, and we will use these displays. We are at the end of this video, and now you have an overview of how to connect the LCD display to your flight sim. And these LCD displays are adding so much value to your sim environment, and you have seen how easy it is to connect it to the sim with MobiFlight. So MobiFlight, again, great job on the LCD displays. You can download the configuration file for MobiFlight. Just follow the link in the description. Again, if you are new to the channel, please subscribe. If you find this video useful, please give it a like. If you have any questions or comments, put them in the comment section below. But for now, just have fun with the LCD displays and see you in the next video.